Oh, now I don't want to record. Now I want to pause. Okay, so we are still working in finding surface area revolution. So we've done two problems so far. This first problem was to find the area of the surface generated by revolving the curve y is equal to 2 the square root of x on the interval from 1 to 2 about the x-axis. We did a second example, but we got to an integral that we could not do because I think I was supposed to revolve that about the y-axis. And so we get to an integral that you're going to learn how to do in this course. Okay, I want to do another example. This one I'm going to revolve about the y-axis, and that is, we want to find the surface area. Find the area of the surface generated by revolving the curve. X is equal to y plus the square root of y on the interval 1, 2 about the y-axis. Okay. Okay, so the curve is x is equal to y plus 2 the square root of y. And I'm on the interval 1 to 2, less than equal to y, less than equal to 2. And I'm revolving that about the y-axis. Okay. All right. Any questions about trying to do that? All right, go ahead and set it up. This one's going about the y-axis. Set it up. So everything is going to be a little different. This one is going to be the area is the integral from C to D of 2 pi x, the square root of 1 plus x prime squared dy. Okay, so that's the problem you are now working on. Okay, so from what I see, this is another one we may not be able to integrate, but the next one you will definitely be able to integrate. I don't know if you can integrate this one until I start doing it, and I don't want you to see my answer. So I want you guys to do it. Any questions so far? Did you already write down what you need? You need x, you need x prime. You need x prime squared. You need the square root of 1 plus x prime squared. You need to simplify that. Okay, what's x prime?
Y to the negative 1/2.
Okay, how about the y part? Okay, it is y plus 2 the square root of y. Okay, so when I take the derivative, I get 1 plus y to the negative 1/2. All right, square that. What do you get? Anybody have an answer? Gustavo,
Would it be y negative 1 plus 2y to the negative 1/2 plus 1?
that looks good to me. Okay, what else do we do with it? Okay. So now we're going to add 1 to it. Y to the negative 1 plus 2y to the negative 1/2 power plus 2. So now I need the square root of that. So if I take out a y, I get 1 plus 2y to the 1/2 power plus 2y. Okay, so the area, the integral, y goes from 1 to 2 of 2 pi. X is y plus 2 the square root of y times the square root of 1 plus 2y to the 1/2 power plus 2y divided by y. dy. Okay, what can I do?
Do the y's cancel out?
Yes. Okay, so this comes out, this actually, I can rewrite it like this. Okay. So now I can see A is equal to the integral from 1 to 2 pi. So now I'm going to get square root of y. So it's going to give me the square root of y plus 2. And then this is the square root of 1 plus 2y to the 1/2 power plus 2y. And then actually to put this inside, I have to put that inside as that thing squared and then simplify. Okay, so the major part of this problem is simplifying all of this. So you have to simplify this thing.
So professor, why are you still have the square root of y? Yes, square root of
Because
y plus
because I took this square root of y here and moved it under these two. So y over the square root of y gave me the square root of y. And 2 the square root of y over the square root of y just gave me 2.
could you write it down?
I'm sorry, say it again.
I said, could you write that down?
I certainly can.
Thank you.
It cracks me up how it moves certain things but doesn't move others. So I made this 2 pi, and then I took this y plus 2 the square root of y, and I put that square root of y underneath it. And then I kept this. So then I was able to simplify this y over the square root of y gave me this, and 2 the square root of y over the square root of y gave me 2. Diara.
Yeah. Okay, thank you. I get
Okay.
it.
All right. I got to find something we can integrate because some of these items found too that we can't integrate. I promise you we should be able to integrate the next one. Okay, because the next one says you should be able to find this by hand. So hopefully this works for us to find it by hand. Okay. Because the ones I had were just, they didn't require anything. Some of these can actually be pretty hard. So I'm going to find, that one's rather easy. Did we do y equal to the square? Oh, we already did a square root one. Let's do another square root one. I don't want to spend our whole class time trying to simplify that thing and integrating it. Y is equal to x cubed over 9. All right, let's try that one. And 0 less than x less than 2 about the x-axis. All right, let's try this one. Hopefully this one is one we can integrate. Y is equal to x cubed over 9. All right, this comes from a section of my book that says it should be integrable. All right, so y is equal to x cubed over 9, y prime. Then bring the 3 down so I get x squared over 3. This one works. So then y prime squared is equal to x to the 4th over 9. So therefore 1 plus y prime squared is 1 plus x to the 4th over 9. So then when I take the square root of that, I get the square root of 1 plus x to the 4th over 9. Okay, so therefore the surface area, the integral from 0 to 2 of 2 pi, y is x cubed over 9 times the square root of 1 plus x to the 4th over 9 dx. Well, why in the world did the other one not work? Did I do it wrong? No, not that one.
So, Professor, why is there a reason why you're not doing it on the graph?
What, why didn't, oh, because I know what the formula is and I just already know the curve.
Oh, okay.
Yeah, so it wasn't, I didn't really need to graph it because I know the curve and I know the formula. It's a simple curve, simple formula, yeah.
So, for the last example that you did for the y plus 2 square root of y, I just want to know how would you do that? How would you put that on the graph?
I don't know what that looks like.
Okay.
Well, if okay, so let me think about that for a moment. Let's just say if it were x is equal to, if it were y,
Yeah, that, and I had put that in Desmos and
you put what in decimals?
Desmos.
Oh, okay. So if this was y is equal to x plus 2 to the square root of x, I know that y equals x looks like this. And y equals the square root 2 to the root of x looks like this. So I would expect that as you're, of course, you're adding these. So I would expect that this function would look something like that because you're adding the points together. So that was what I would expect it would look like.
The y plus 2 square root of y.
So no, that's x plus 2 to the square root of
okay.
x. So now y plus 2 to the square root of y is going to be a different shape. It's going to be, So it's going, actually, remember, we did, it's going to be, it would look like this. Is that what you got?
Yeah, okay.
It would look like X is equal to Y plus 2 the root of Y. I think would be like the black line. Yeah. Okay. All right, how do you integrate that? That one's easy. Thank God we got something easy to integrate. Easy, easy, easy. Hello. How do I integrate this?
Would you get rid of the square root first?
Well, I can't get rid of it. I can't do anything with it. So I do know that if I let this be u, its derivative is sitting right there. So if I let u equal 1 plus x to the 4th over 9, then du is 4x cubed over 9 dx. And that would say then that x cubed dx would equal 9 over 4 du. Then I will also have, when x is equal to 0, u is equal to 1. And when x is equal to 2, u would be 1 plus 16 over 9, which would be 25 over 9. Okay. So therefore, this would be, take the 2 pi, okay. Take the 2 pi over 9 out. The integral from 0 to 2 of x cubed, the square root of 1 plus x to the 4th over 9 dx. So this would be 2 pi over 9. The integral when x is 0, u is 1. When x is 2, u is 25 over 9. And then this would be the square root of 1 plus x to the 4th over 9 would be the square root of u. And then x cubed dx well, I see x cubed dx is 9 over 4 du. So therefore, I'm going to end up with pi over 2. Then I'm going to integrate u to the 1/2. So I'm going to get 2/3 u to the 3/2 power. And then I'm going to evaluate that from 1 to 25 over 9. So that looks like pi over 3. And then I'm going to get 25 over 9 to the 3/2 power minus 1. Okay. Now 25 over 9, if I take the square root of that, that gives me 5/3. And then I cube it, that gives me 125 over 27. So this becomes pi over 3. This number becomes 125 over 27 minus 1. So I'm going to rewrite that as 27 over 27. So I get pi over 3. And then I'm going to get 98 over 27, which becomes 98 pi over 81. Okay. Any questions? Recap. Started with y, found y prime, found y prime squared, found 1 plus y prime squared, put it inside the square root, then put that in the integral with f of x or y. Then did a u substitution, let u equal to x to the 4th over 9, found du, found what x squared is, x cubed is in terms of du, put everything in. The big key here was when u equaled 2, you got 16 over 9. And then that gave you 25 over 9, which was a perfect square. So that was nice. So the fact that that was a perfect square, when I integrated that and I got 3/2, 2/3, I get pi over 3 because the 2's divide out. And then I'm raised to 25 over 9 to the 3/2 power. The square root of that is 5 over 3. Cube it, 125 over 27. Subtract 1. Becomes 98 over. Yep, I'm happy with that. Okay, that would be an expected surface area problem on the test. You would get something just that simple. It works out beautifully. There's nothing hard to integrate. Nice problem.
Dr. Long,
Yes.
for like if you go up the portion of the problem that shows x cubed dx, so you calculate it as 9 over 4 du.
Yes. So that came from me taking the derivative. I brought the 4 down, so that becomes 4x cubed over 9. But then I have this 4/9 cubed dx. So I took this piece, solved for it, and threw the 9/4 to the other side. So now, once I do my substitution, the only thing that's left is x cubed dx. And that is 9/4 du.
Okay, so you just transfer that part of the equation
Yep.
to the other.
This is a perfect problem. I mean, you can't get any more perfect and beautiful than this one.
Okay.
And then the fact that the limits turn out to be something that's a perfect square, they did a nice job on choosing this problem. Some problems are not nice. This one is nice. Okay, one more. You guys are going to do this one. Oh, did I? Find the surface area of the object, which is obtained by revolving the curve. This curve is not cute. I have no idea what this answer is going to look like. Okay, so here's the curve. Y is equal to the square root of 2x minus x squared. On the interval 1/2 less than x less than 3/2. About the x-axis. Okay, let's get going. You know what to do. Camera's on. I can't see you working. Okay, good. Progress, anyone? Who wants to give me y prime?
I can give you y prime.
Okay,
So since we know y is square root of 2x minus x squared, y prime is square root of 2 minus 2x.
how did you get that?
Oh, I still kept the square root. I just did the derivatives of the inside values under the square root.
And is the square root happy that you threw him away?
I
No.
don't know.
No, square root not happy. You threw him away.
Oh, I see now. Oh. Yeah, I'm gonna have to go back on that.
Okay, no problem. How do you take the derivative of this thing?
Would it be 1 minus x over 2x minus x squared all raised to the 1/2?
That is correct. Okay, so y is equal to 2x minus x squared to the 1/2 power. So y prime is 1/2 times 2x minus x squared to the negative 1/2 power times 2 minus 2x. And so those 2's are going to divide out. So you get y prime is equal to 1 minus x divided by the square root of 2x minus x squared. Okay, so far so good. Now we got to square that. So y prime squared becomes 1 minus x squared divided by the square root, oh, I'm sorry, of 2x minus x squared. Okay. So therefore, 1 plus y prime squared becomes 1 plus 1 minus 2x plus x squared divided by 2x minus x squared. But that looks like 2x minus x squared. Oh, how wonderful. Plus 1 minus 2x plus x squared. How beautiful is that? It looks scary, but it's not. Over 2x minus x squared. So 1 plus y prime squared. Well, this 2x and that 2x are gone, and this x squared and that x squared are gone. So the only thing I get in the numerator is 1 over the square root of 1 over 2x minus x squared. Wow, that is gorgeous. Because now the square root of that thing y prime squared is just 1 over the square root of 2x minus x squared. So now when I put it all together, I get my area is the integral from 1/2 to 3/2 of 2 pi. Y was the square root of 2x minus x squared. And then when I multiply by the square root of 1 plus y prime squared, that is just 1 over that thing. And guess what? They cancel. So I have nothing to integrate. So the area is the 2 pi times the integral of 1/2 and 3x dx. So that's 2 pi x evaluated between 3/2 and 1/2. So that becomes 2 pi times 3/2 minus 1/2. Man, what a beautiful problem. And honestly, there was very little calculus. This problem was mostly algebra. Calculus, we had this was the formula. We took the derivative. We squared it. We added 1 to it. Wow, beautiful problem.
Yeah, I forgot about that square root. That actually really threw me off. I would have gotten a completely different answer.
What, this one?
Oh no, I'm talking about like doing the derivative, finding y first.
Oh, yes, yes,
and y
yes,
prime.
yes.
So I have to go
It
back to
did.
that and make sure.
Okay, so Monday, we are on to another topic. You guys have an exam on Thursday of next week. Okay. Take care. I'll see you later.
Professor,
Yes.
can you send like an announcement or something on Blackboard